Alright, so in this video, I'm going to solve the equation x to the power of 12 minus 1 is equal to 0. So to solve this, I'm going to first rewrite this as x to the power of 6 to the power of 2 minus 1 squared is equal to 0. And the reason I'm doing this is so I can use the property a squared minus b squared is equal to a plus b times a minus b. So this turns into x to the power of 6 plus 1 times x to the power of 6 minus 1 is equal to 0. So this gives me two equations. I get x to the power of 6 plus 1 equals 0, and x to the power of 6 minus 1 equals 0. Now I'm going to do the same thing again. I'm going to rewrite x to the power of 6 minus 1 equals 0 as x to the power of 3 to the power of 2 minus 1 squared is equal to 0. So I can use this property again and get x to the power of 3 plus 1 times x to the power of 3 minus 1 is equal to 0. Now, for x to the power of 3 minus 1 equals 0, I'm going to rewrite this as x to the power of 3 minus 1 to the power of 3 equals 0, so I can use the property a to the power of 3 minus b to the power of 3 is equal to a minus b times a squared plus ab plus b squared. So this turns into a minus b times a squared plus a plus 1 is equal to 0. Sorry, this turns into x minus 1 times x squared plus x plus 1 is equal to 0, which gives me yet another two equations. So now I have x minus 1 equals 0 and x squared plus x plus 1 equals 0. So for x minus 1 equals 0, all I have to do is add 1 on both sides, and I get x is equal to 1. And for x squared plus x plus 1 equals 0, I can use the quadratic formula. So by using it, I get x is equal to negative 1 plus or minus the square root of 3i over 2. So these are two more solutions. And now we aren't done yet because we also have to solve these. So now I have x to the power of 3 plus 1 is equal to 0. And I'm going to subtract 1 on both sides, so I get x to the power of 3 is equal to negative 1, meaning x is also equal to negative 1. So this is another solution. Now for x to the power of 6 plus 1 equals 0, I'm going to again subtract 1 on both sides. So I get x to the power of 6 is equal to negative 1. And if I take the 6th root, I get x is equal to 6th root of negative 1, which is equal to negative 1 to the power of 1 over 6. So now, the 6th root of negative 1 is, we know that I is equal to the square root of negative 1, which is equal to negative 1 to the power of 1/2. So negative 1 to the power of 1 over 6 is the same thing as negative 1 to the power of 1/2 minus something. So now 1 over 6, or I should say 1/2 minus 1 over 6 is equal to 1 over 3. So 1 over 6 plus 1 over 3 is equal to 1/2. We know this. Meaning we have negative 1 to the power of 1 over 6 and this plus, or sorry, 1 over 2 minus 1 over 3 is what we can rewrite 1 over 6 as. Now, this is the same thing as 1/2 plus negative 1 over 3. And if I have something in the form a to the power of m plus n, This is equal to a to the power of m times a to the power of n. So this is going to equal negative 1 to the power of 1/2 times negative 1 to the power of negative 1 over 3. Negative 1 to the power of 1/2 is the square root of negative 1, which is equal to I. So we get I times negative 1 to the power of negative 1 over 3, which is the same thing as 1 over negative 1 to the power of 1 over 3, which is equal to negative 1. So I get I times negative 1, which is equal to negative I, which is my final solution.
Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve the exponential problem 8 to the power of 8 plus 8 to the power of 8 plus 8 to the power of 8 plus 8 to the power of 8. Now, to solve this problem, what I'm going to do is, well, I first have 4 answer choices. So my first answer choice, A, this is going to be 8 to the power of 32. My second answer choice, B, this is going to be 32 to the power of 8. My third answer choice, C, this is going to be 32 to the power of 32. And my final answer choice, D, this is going to be 2 to the power of 26. So if you guys know how to solve this problem, you guys can try to find out which answer choice this is. Alright, so now, to solve this problem, well, let's first go through all the answer choices, starting with A. How they got A was they kept the base the same, so they did 8 to the power of, then they added all the exponents, so 8 plus 8 plus 8 plus 8. And this is equal to 8 to the power of 8 plus 8 is 16, 16 plus 8 is 24, 24 plus 8 is 32. And this method is actually wrong. You can't add exponents like that. So for the secondary choice, B, they got 32 to the power of 8, and how they got this was they kept the exponents the same, and they added the bases. So they did 8 plus 8 plus 8 plus 8 to the power of 32. To the power of 8. Now, 8, this is the same thing as 8 to the power times 4, which is 32. So I got 32 to the power of 8. And this method is actually wrong as well. This is not the right way to add exponents. Now, for 32 to the power of 32, they did both. They added all the exponents and the bases. So they did 8 plus 8 plus 8 plus 8 to the power of 8 plus 8 plus 8 plus 8. And they got 32 to the power of 32. And this method is wrong as well. Finally, for D, which is actually the right answer, they first started with, well, 8. This is the same thing as 2 to the power of 3, right? So we have 8 to the power of 8 plus 8 to the power of 8 plus 8 to the power of 8 plus 8 to the power of 8. And now if I substitute in 2 to the power of 3, I get 2 to the power of 3 to the power of 8 plus 2 to the power of 3 to the power of 8 plus 2 to the power of 3 to the power of 8 plus 2 to the power of 3 to the power of 8. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So in this case, a is equal to 2, m is equal to 3, and n is equal to 8. So now I have 2 to the power of 3 times 8 plus 2 to the power of 3 times 8 plus 2 to the power of 3 times 8 plus 2 to the power of 3 times 8. Now 3 times 8, this is the same thing as 24. So now I have 2 to the power of 24 plus 2 to the power of 24 plus 2 to the power of 24 plus 2 to the power of 24. Now from this, I'll factor out 2 to the power of 24. So now I have 2 to the power of 24 times 2 to the power of 24 divided by 2 to the power of 24 is 1. So I have 1 plus 1 plus 1 plus 1. And if I simplify this in the parentheses, I get 2 to the power of 24 times 4. 4 is the same thing as 2 squared, so now I have 2 to the power of 24 times 2 squared. And now if I have something in the form a to the power of m to the power of n, this is equal, or sorry, if I have something in the form a to the power of m times a to the power of n, this is the same thing as a to the power of m plus n. So 2 to the power of 24 times 2 squared, this would be 2 to the power of 24 plus 2, which is equal to 2 to the power of 26. So this is why our right answer is D. Now it's time for our bonus problem. 3,111 squared plus 2,889 squared. Now the first thing I'm going to do is I'm going to rewrite this as 3,000 plus 111 squared plus 3,000 minus 111 squared. Now I'm going to set A equal to 3,000, and I'm going to set B equal to 111. So now, if I substitute these in, I get A plus B squared plus A minus B squared. Now A plus B squared, this is equal to A squared plus 2AB plus B squared. And A minus B squared, this is equal to A squared minus 2AB plus B squared. So now, if I add these two together, I get A squared plus 2AB plus B squared plus A squared minus 2AB plus B squared. So first off, these two will cancel out, and I'll be left with A squared plus B squared plus A squared plus B squared, which is equal to 2A squared plus 2B squared. Now if I factor out 2 from this, I get 2 times A squared plus B squared. Now remember how we set A equal to 3,000 and B equal to 111. So now if I substitute these values back into here, I get 2 times A squared, so 3,000 squared, plus B squared, so 111 squared. Now 3,000 squared, this is the same thing as 3,000 times 3,000, right? And you may think this is hard because it's a 4-digit number times a 4-digit number, but we can actually for now ignore the zeros and we can just do 3 times 3. So that would give us 9, right? And then we simply add all the zeros after. So we're going to add 1, 2, 3, 4, 5, 6 zeros. So 1, 2, 3, 4, 5, 6 zeros. So our answer here is going to be 9 million. So now I have 2 times 9 million plus 111 squared. Now for 111 squared, this is equal to 111 times 111. Now, if we try to do this, 1 times 1 is 1, 1, 1, 1, 1, 1, 1, 1, 1. So I have 1, 2, 3, 2, 1, which is our answer. Now, 9 million plus 12,321 is going to be 9 million, 2 times 9012321. And this is going to equal 18,024,642. So this is our answer.